Hello, hello, hello. This is Nicholas. I am doing a quick proof of the geometric mean inequality that I used, or equality, not inequality, geometric mean equality. And so here's the proof. We have this triangle ABC. It has side lengths of A, B, and C, little a, little b, little c, and I've divided side length C into a length of P and a length of Q. And what the geometric mean theorem says is that this length H is the geometric mean of P and Q. In other words, H is equal to square root PQ. Another way you might see it written as is that P over H is H over Q. Those say the same thing because if you cross multiply, H squared is equal to PQ, which says they all say the same thing. Just you see it written both ways. I use this way in my Pythagorean theorem proof. So what am I going to do? We have three similar triangles here. We have the full triangle ABC. Then we have the smaller triangle ACD. That's this triangle right here. And then we have BCD. That's this triangle right here. And those are similar triangles. So we can get some information about them. So first of all, we know from triangle ABC that C squared is A squared plus B squared. We know that from triangle ACD, the red triangle, that H squared is B squared minus P squared. And from the blue triangle BCD, we know that H squared is A squared minus Q squared. So I'm going to add these two equations, and I get that 2h squared is A squared plus B squared minus P squared minus Q squared, which is C squared minus P squared minus, I wrote P to the Q, P squared minus Q squared, which C squared, C squared, C, remember, here is P plus Q, so I want it just in terms of P plus Q, so I'm going to replace the C with P plus Q squared minus P squared minus Q squared, which is just going to give me, when I FOIL that out, I'll get P squared plus Q squared plus 2PQ, and then that's going to cancel out with the minus P squared minus Q squared, so we're just going to get 2PQ. So this is equal to 2h squared, and so then h squared is equal to PQ. And that proves